Hello class, Assalamualaikum and good morning. I hope that all of my students are staying at home and stay healthy with your family. We need to follow the government order to wash hand frequently. If you got a symptom, just go directly to hospital to get a further checkup. And the most important thing, student, you need to remember, you need to stay at home to break down the change of COVID-19. Okay, last week you have learned about gravitational. So today I am going to continue the new lesson with the new lesson. Before I start my lesson, I want to tell you a story. Do you realize that nowadays weather are unpredictable? Sometimes we got rain, sometimes we got very hot weather. When you feel hot, you need something to make you cool. For example, aircon, fan. So imagine that you are very hot. You feel very hot, and then you go to a room with air conditioner. So do you realize that when you enter the room, you are getting cold? Suddenly, immediately you are getting cold. Okay, that is what we are going to learn today. We are going to learn about heat. So from the hot to the cool field. So class, today we are going to learn about how to explain through example of thermal equilibrium in daily life, and then you are going to learn how to calibrate a liquid in gas thermometer using two fixed point. So these I provide the success criteria for today's lesson. Okay class, in today's lesson we are going to use the mind map that I give to you. Okay, what is thermal equilibrium? What is heat? So I have been highlight the four important things here. So as you can see here, we have four important things, right? So the first one is heat is a form of energy. Okay, heat is the form of energy that flows from the hot region to cool region. So the key point here is, okay, the key point here is, okay, first one, okay, heat is energy. Remember, energy that flows from hot region to cool region. Okay, remember, hot region to cool region. Okay, let's see the second point. Okay, so the second point, as you can see here, okay, the second point is heat can heat up or cool down an object. And then the third point is heat can be used to know whether an object is hot or cold by measuring the temperature. Okay, now let's go to the second point. Okay, the second point, okay, heat can be used to heat up or cool down an object. Okay, remember, heat can be used to heat up and cool down an object. And then the third point is a very important point. Heat can be used to know whether the object is hot or cold by measuring the temperature. So by measuring the temperature, okay, so that means if the temperature is higher, so that means the object is hot. Okay, remember this. If the temperature is lower, that means the object is cool. Okay, and then the last thing you need to know, in heat, you need to know the SI unit. So as heat is energy, so means the SI unit is in joule. Remember, J is joule. Okay, remember that. Okay, now we are going to proceed to the activity in this topic to make you more understand about this topic. So let's do an activity. Okay class, now we are going to do the activity. So in my hand, I have a cup of plain water with the ice cube and also the hot coffee, as you can see here. So this is actually a Nescafe. Okay, and now I am going to pour the hot coffee inside the cool water. So as you can see here. Okay, now This is how the thermal equilibrium happen when the hot water become warm and the cool water not cold anymore. They both become warm because they are heat flow, and then they are heat flow and the temperature is become the same. As you can see here, I will explain further in the explanation after this. Okay. Okay class, we have done the activity just now, but you wonder, right, what is the activity about? So the activity we drew just now is about to study the thermal equilibrium between two bodies in thermal contact. So as you can see in the, as you can see here, we mix together with coffee and cool plain water, right? Okay, and then I want you to remember that, as you can see here, this one, I want to remember that heat can change physical state or temperature. So as you can see here, the first condition I tell you is if physical state remain unchanged, the temperature is changed. The second condition is if the temperature change, so means physical state is remain unchanged. Okay, remember this table. Okay, now we are going to proceed to the diagram here. Okay, you can see that the diagram here. Okay, this is the condition where the heat from coffee is a bigger heat want to transfer to cool plain water. That's mean the condition we doesn't mix the coffee and cool plain water yet. And then the second one is when we mix the hot coffee and cool plain water. So as you can see, the bigger heat transferred to the cool plain water and the smaller heat is transferred to a hot coffee. This is because the temperature of cool water is lower than the temperature of hot coffee. So that's mean the cool water flows a low heat. Okay, so it's mixed like this. Okay, and then when the thermal equilibrium happens, so that's mean the cool and hot water will have a same temperature. We've already mixed, and then hot water and cool water will have same temperature. That's mean the hot water is not hot anymore. The cool water is not cool anymore. That's mean the mix of two water is getting warm. So that's why the temperature is same. The heat already flows into the cool water and plain water. So that's mean that is why the thermal equilibrium happen. Okay, understand class? Okay class, now we are going to continue with the application of thermal equilibrium in daily life. So in the mind map, as you can see here, we have two conditions, which is heating object and cooling object. So as you can see in the heating object part, there is a girl having a fever, right? So when you go to the doctor and you having fever, doctor will take your body temperature by using this kind of digital thermometer. Okay, this one is called as digital thermometer, and the digital thermometer have the bulb. So how the doctor can take your temperature? So the bulb will have a contact with your body, okay, which is doctor put under your tongue, and then they will have thermal contact, right? So that's mean doctor will wait until the net heat first become 0, and then the temperature between this bulb and your temperature is same, and then that's how the doctor can take your temperature. Okay, as you can see here, for cooling object, there is a hot meat and cool water, right? So if you want to give a baby meat, you cannot give a hot meat because the baby will having pain. So you need to give a warm milk. So how to make the milk warm? So you have a cool water, and then you put the bottle or the bottle with hot milk into the cool water, and then they are having a thermal contact, right? So the temperature between the hot milk and the cool water becomes same. So the hot milk already warm, and you can give to baby, and they can drink well. Okay class, there are many kind of situation that related to thermal equilibrium. You can find more in Google, also in your textbook you can find the example. Okay. Okay, class. Now I want to teach you about how to calibrate a liquid in-gas thermometer using two fixed point. Okay. Now, as you can see in the mind map, I've been draw a thermometer, right? So there are four types of thermometer. The first type of thermometer is liquid in-gas thermometer. Remember, liquid in-gas thermometer. So liquid in-gas thermometer divided into two. So the first one is mercury. Okay, the second one is alcohol. Okay, next we also have thermocouple thermometer. Okay, next we have resistant thermometer, and the last one is gas thermometer. The characteristic of this thermometer is, the first one, the volume of, the volume of mercury column change with heat. Okay, for the thermocouple thermometer, the EMF and current change with heat. This is the characteristic. Okay, you can write down here in the blank here. Okay, the resistant thermometer, the characteristic is the resistance change with heat. Okay, for the gas thermometer, the characteristic is the gas change with heat. Okay, that is all the characteristic of the thermometer. Okay, class. Now I am going to teach you about the calibration of thermometer. Okay. What is calibration of thermometer? Calibration of thermometer means marking scale for new thermometer. So between two fixed points. So what is two fixed point? Okay, between two fixed point. Two fixed point mean 100 degrees Celsius and 0 degrees Celsius means we put the temperature inside the boiling water, and also this for the 0 temperature we put the temperature inside the ice cube, a beaker with ice cube. So what is the formula? The formula is any temperature except for 0 degrees Celsius and 100 degrees Celsius. Okay, this means that this temperature can be any temperature except for 0 degrees Celsius and 100 degrees Celsius, equal to the length of any unknown temperature minus the length at 0 degrees Celsius divided by the length of 100 degrees Celsius minus the length at 0 degrees Celsius. So as we know, this is the length of temperature. Okay, this one is the length of temperature. This one is length at 0 degrees Celsius. This one is length at 100 degrees Celsius. So how to solve the equation? How we can know where is the length at 0, length at 100 degrees Celsius? So this is how we know the length. Okay, imagine that this is a thermometer. Okay, so this is between this point to this point is length at 100 degrees Celsius. So between 0 point to any point here, this called as length of temperature at 0 degrees Celsius. So this is the length of unknown temperature. So we know there's a length of unknown temperature. So all the lengths will be given in the question, and then you need to solve the question by substitute all the information given into each of the formula. So on next class, we will solve a question about calibration of thermometer. Okay, now we are going to conclude our lesson. So today, what we have learned? We have learned many things, right? So the first thing is we learned about thermal equilibrium. So how many important things we need to remember? There are 4 important things you need to remember. Okay, and then we are already do activity about the hot coffee and also the plain water. Okay, you need to remember how it's happened, the physical the physical state, the temperature remain unchanged or unchanged, and then you also need to know about the heat flows between the hot coffee and also the cold water. And then we also learn about the application of thermal equilibrium in daily life. So you need to remember for heating object, cooling object. Okay, and then we also learn about thermometer, right? There are 4 types of thermometer. For liquid and gas, we have 2 types. And then we learn about the formula of thermometer calibration. You need to remember. And then when you do the activity during at your school, you can use this formula to solve the question. Okay, thank you class.